So now that we talked about the difference between population and a sample and a statistic and a parameter, we want to talk about where we're getting our data. So, population, that's the entire set of individuals or objects being studied. We said we could define it however we want, but that whole group is what we're studying, the population. What we're studying about that population can be expressed in terms of a parameter, which summarizes a characteristic of a population. If we're talking about something that's numerical, we would talk about the mean of the population and the standard deviation of the population. And if we're talking about something that was categorical, we would talk about the proportion of the population. Okay? And so the parameter describes a characteristic of the population, so we can remember that because population and parameter both start with P, and so they go together. Okay? But most of the time, we're actually not going to look at everything in the population. We're going to take a sample. So we want to talk about that. What a sample is just a subset of the entire population. So if we're looking at this Venn diagram, we've got the whole population there, and then a sample is just a set drawn from that population, but much smaller number of people or items. Okay? So, sample is a subset. Now, what we're studying, the characteristic, that's summarized by a statistic. And so, for the statistic, we can talk about the mean of the sample, that's a statistic, or the standard deviation of the sample, if we're talking numerical. And if we're talking categorical, we could talk about the proportion of a sample and that statistic. And we'll talk about how we symbolize that. And so we can fill in our chart for numerical data first. And for numerical data, we have mean, standard deviation, and variance. And so mean and standard deviation, you might have seen before when you did normal distribution stuff, we used mean. And so the parameter, which describes the whole population. So for the mean, that symbol is a mu, a Greek letter. A lot of times you'll have a Greek letter describe the population and a regular letter describe a sample. So mean, mu is the sample for the mean of the whole population. And for the mean of a sample, that's called x with a bar on top of it, which we call x bar. Now, so this is kind of a measure of central tendency. Standard deviation and variance are measures of spread, which we'll talk about more later, the spread of data. And so for the standard deviation, we use this quite a bit, and you might have remembered this from your days in doing the normal distribution. That was the denominator, calculating a z-score. And standard deviation for a statistic is an S. So your sigma is the standard deviation of the population, and S is standard deviation of your sample. And variance, all that is the standard deviation squared. And in how it's derived, you'd actually find the variance first and then take the square root to find the standard deviation. And intuitively, it makes sense that sigma would be the square root of sigma squared. Okay, and so that's for numerical data. For categorical data, we have other symbols. It's less complicated. For our proportion, the proportion of a whole population, for example, if we talk about the proportion of people who are in support of affirmative action, for the entire population, that proportion would be P. Now, some people identify that P stands for parameter. It does not. P stands for proportion of the entire population. P of the entire population. Or some people think it stands for population, but it's the proportion of the population. And if we took a sample, the proportion of the sample also has a P, but this has a hat on it, and we call it P hat. And so this is a sample proportion, which is P hat. So those are our symbols that we're going to use throughout the year. Mu and x bar for means, sigma and s, sigma squared and s squared, for measures of spread, and for proportions, p and p hat. And for all of these, we're always going to be talking about the sample size, which we said was n before. And so I would put that in the column for numerical and for categorical data. Okay. So why do we use this? These symbols, it makes it easy for us, and we're using statistics to summarize and organize and simplify, kind of be able to communicate. Okay, so here is a chart of data. We want to kind of go over how to read this data, because you can kind of know the calculations, but you have to be able to understand what you're looking at here. So this was drawn from the census that was drawn in 2000, and it records 7 different characteristics of these 10 people, of all these 10 people. And so I don't want to take it for granted that you know what we're looking at here. So if you want to pause it and kind of study this, you can. Okay, and I'll go through a couple of the people. And so the answer to this: who are the individuals in this data set? Okay. These 10 Americans. We were told, here's information about 10 randomly selected U.S. residents. We have a tendency in math, in general, to, when the words are at the top, we kind of gloss over that and read the chart, because that's where the action is. But we want to make sure that we know what we're talking about, because we're going to need to know context of all the problems that we're working on. So that's the, okay. And then, so what variables are being measured, and identifies each as categorical or quantitative. You might want to try this on your own first to see it, with those kind of rules of what's quantitative and what's not. And so if you're not pausing, or if you pause and come back. For the state, that's categorical. It's answered with a word. Number of family members, it's answered with a number, and an average makes sense, so that's numerical. Age, answered with a number, average makes sense, that's numerical. Gender, male or female, answered with a word, that's categorical. Marital status, married, never married, separated, those are all categorized, so it's categorical data. Total income, numerical, and average makes sense. Time to work, travel time to work, that's also numerical. Okay, and so here's one about not being sloppy. It doesn't have the units either in travel time to work, or total income, or technically in age, although we assume that's years, and we already, for a number of family members, we don't need units there. But you would want to see units reflected in that. Okay. Okay. So it says, there's our listing of there. And so describe the individual in the first row. This is a 61-year-old female Kentuckian who is married with a total of income of $21,000, who takes 20 minutes to go to work. Okay. Just following all that information. The one person who always fascinates me, what the story behind them is this person in the 8th row. Okay? Who has 4 family members, 22 years old, male, never married, and single, makes $3,000 a year with a 0 travel time to work. So maybe this person went to school and then now is living at home with his family, and is making $3,000 online. I don't know. Maybe he works a paper route, something. But you can kind of get a story of someone just with these 7 pieces of information, and you can speculate, but it helps you. Okay. And so for these examples in here, you want to find the population being studied, whether what variables are present, quantitative, qualitative, and identifying. So for the first one, this Chevy is studying the efficiency of their 2012 Chevy Volt. The 2012 represents the year of that. It's not that there's 2012 of them. And it has an average miles per gallon of 65.5, So your population are all the Chevy Volt hybrids ever made. Your variable is miles per gallon, which is quantitative. You need to use a number to describe that. And the value of that is 65.5 miles per gallon, which is a statistic. Because, why is it a statistic? Because it's drawn from a sample of 35 cars. It's not the parameter, we don't know all of them, but from these, we assume they made more than 35 volts. For the second one, candidate is exploring chances of winning an election. So 56% of 2,200 people polled in the DC area responded that they would vote for them. The population is DC voters. The variable is voter support. Are you voting for the candidate or are you voting for somebody else? Qualitative, you're putting it in different categories. And your value is 56%. So that meant 112 out of the 200 people said, yes, we're voting for this candidate. And so you find out the proportion by doing what you're looking for, which is, in this case, the number of people that are going to vote for this candidate out of the entire sample size. Then this last one says, Mr. Hood wants to know how Madison students compare to the rest of the nation. So SAD reports 72% of all high school seniors have consumed alcohol during time in high school. In a recent survey of 100 Madison seniors randomly surveyed, 65 have consumed alcohol. This is an example of kind of needing to be exact and not being sloppy about what. So you could, because it looks like there's a bunch of different potential populations. It says Mr. Hood wants to know about Madison students. So you could say Madison students are the population. But they're using a statistic here, or actually theoretically a parameter from SAD that says 72% of all high school seniors. Okay, well that population is all high school seniors everywhere, not just Madison students. And then they surveyed 100 random seniors at Madison. Well, Mr. Hood originally wanted to know about all Madison students. So seniors, there's certainly more than just seniors at Madison. So this is true. Again, you need to be precise in how they're measuring and how they word things. Okay? So we'll take a break here.